Hey everyone, I am Priyanshi and welcome back to my channel. Today we will be solving the question count the number of consistent strings. So it is quite boring and simple question, but I will be telling you in another approach for this question using bit manipulation, which is quite interesting for this one. So we will be looking at both the approaches. So let's see how we can solve it. So in this question you are given a string allowed consisting of distinct characters and an array of string words. Okay, and a string is consistent if all the characters in the string appear in the string allowed. And we need to return the number of consistent strings in the array words. Okay, so let's see what is this question. So in this question we have been given with a string allowed and a vector of strings words. And we need to return the number of consistent strings from these words. And a string is consistent if all the characters of that string appear in this allowed. Okay, so it is quite simple and iterative approach that we can iterate all the strings of this word, and we will need to iterate all the characters of a string, and we need to look for that character in allowed, whether that character occurs in this allowed string or not. If not, then we will not count this string, otherwise we will count this string. So what will be its time complexity? Okay, so see, the length of words can go up to maximum of 10 to the power 4, and the length of a string in the word can go up to 10. Okay, so this can go up to 10 to the power 4, this can go up to 10, and what this can go up to? See, we have been given with distinct character. This is an string of distinct characters, so this can go up to only 26, right? So its complexity will become big O of 10 to the power 5 into 26. Cool. Okay, so what we can do here is, as we are iterating this complete complete string for the lookup, so what we can do is we can store all the elements or the character of that of that string in a hash set, right? And then instead of iterating this, we can use a hash set for the lookup, right? So then its complexity will become big O of 1, right? So it will become then, so it is not a big optimization as in this approach. Then the space complexity of hash set will come into picture, that big O of 26. But yeah, this is also a constant number, so we can say it is also a constant, so big O of 1. Yeah, but we are reducing the time complexity by some extent. Okay, so let's see how we can code this. So first of all, we need to create a set of characters, and then we need to store all the characters of the allowed in this set. st.insert id. Good. And then we need to iterate all the strings of the words. Okay, let's say string word is equals to word of I, right? This will be words dot size. Yes, now we need to iterate all the characters of that string. J is equals to 0, j is less than word dot length j plus plus, and we need to check if set doesn't contains that word, right? Then this is not a consistent string. Okay, so let's suppose all these strings are consistent. It means words dot size, all these strings are consistent. But if set does not contains that character, then it means that string is not consistent. Then we will simply decrement our result count, and we will not check for further characters of that string. and by the end of this loop we will finally return our result. Okay, so let's try run this. What I have done is, oh sorry, words of I. It's my network. I don't know why it's taking so much time. Let me just reload the page once. Yeah, now let's try run this. Yeah, now let's try submitting this. Yeah, cool. So in this approach, the time complexity will become the size of the vector multiplied by the size of the string in that vector, and it is big of 1 for an unordered set. Okay, now let's see another approach for which we were talking. Okay, so in the another approach we can use a bit mask to solve this question. So I would say it is already the approach we have just seen using the hash set is already an optimized one. We are not going to optimize it to any greater extent in using the bit mask, but yeah, what's the harm in looking at another solution, and we understand a new concept, because bit mask is the concept which most of the student finds difficult. So let's see how we can solve this question using the bit mask. So we can have a bit mask of up to 32 bits, right? And we have only alphabets, so unique alphabets are 26 only. So yeah, we can use a bit mask here. Okay, so first of all we will create a bit mask of this allowed string. Let's see how. So let's see, we initialize our bit mask with 0. Obviously bit mask will be initialized with 0. Now how we will store these allowed characters in this bit mask? So in this bit mask, 0 will correspond to A, the bit at the first index will correspond to the B character, the bit at the second index will correspond to the C character, the bit at the third index will correspond to the D character, and so on, right? So now the point is that how we will store this. So see, if the allowed string has character D, then it will become 1 0 0 0. If the allowed string has character D C as well, then the bit mask will become 1 1 0 0, because the bit should be set at that index if that character exists in our allowed string. Okay, cool. So in this allowed string, first our string contains A. Now how we will make this bit set in this string? So what we will do is we will simply perform an OR operation of this bit mask with one left shift of our character minus A. So see how it will work. So one left shift of A will give us, right now we are at A, so A minus A will give us 0. So one left shift 0 will give us 0 0 0 1. And when we perform this bit mask and OR operation with this one, then it will give me 0 0 0 1. So yeah, we have got that our A as a set bit. Now let's see for B as well. So in this, what we will do is one left shift of character minus A, it means B minus A, which is 1. So now our mask will become one left shift 1, so which is 0 0 1 0. 1 is shifted by 1 position, 1 is shifted to left by 1 position. Now we will again perform all operation of this new bit mask, not this old one, of this new bit mask with this. So 0 0 1 0 1 1 0 1. So now we have came to the end of our allowed string, and we have finally got our bit mask, right? Now in this approach, what we are going to do is we are going to use this bit mask for the lookup of characters of the word, because in the earlier approach we were using the HashSet for the lookup, but in this approach we will be using this one. So see, we can say that in the other approach the space complexity was big of 26 because of we are using the HashSet and we are showing all the characters, and now we are just here using this bit mask for the lookup. So we can say that we have optimized this space complexity in this approach, not to a bigger extent, but yeah, to some extent. So let's see how we can now use this bit mask for the lookup. So let's say our first string is AD in our words is vector. Okay, so now start iterating all the characters of this string. So first our character is A. Now how will we check whether this mask contains A or not? Okay, if okay, so let's see. First of all, we need to create the bit mask of A. So we have seen that how we can create the bit mask of A. This is the bit mask of A. 1 left shift A minus A, that is 0, right? So it will become 0 0 0 1. So now can we perform the AND operation of these two? So what we will get is 0 0 0 1. Yeah, we have got that 1 is set at this position. So see, if 1 is not set in this bit mask, then we must have got 0 here. If 1 is set, only then we will get 1 here. So it means yes, it contains A. Now let's check for another character in this bit mask. So 0 0 1 1 and 1 left shift D minus A, 1 left shift 3, which is 1 0 0 0, and we are doing it AND with this one. So what we will get is 0 0 0 0. Oh, we have got 0. It means no, D doesn't exist in our bit mask. D doesn't exist in our allowed string. So here what we are doing is we are iterating all the characters of that string and creating their bit mask, and after creating their bit mask we are performing the AND operation with our allowed bit mask. If we are getting 0 after performing the AND operation, it means that that character doesn't exist in our string. Otherwise that character exists in our string. Similarly, we will do this thing for all the strings in our words vector, right? So what we are doing here in our bit manipulation approach is we are just initializing our bit mask as 0 and then creating our bit mask for the allowed characters, for the allowed string I would say, and then we are checking for all the characters of all these strings in the words by creating their bit mask and performing the AND operation with our initial bit mask. If we are getting the value as 0, then no, that character doesn't exist. Otherwise that character exists in our allowed string. Okay, so let's see how we can code it. So let me just remove it. So what we need to do is we need to first create our bit mask for auto it allowed, and how we will be creating our bit mask is bit set. We were performing the OR operation, right? So 1 left shift, let me just say character minus A, right, using the ASCII values. Okay, now what we need to do is again we will be initializing our result as words dot size, and then start iterating for all the strings in that vector, and then we'll iterate for all the characters in that string, and then we check if 1 left shift of word of I, word of J, yeah, it means that character minus A, and we perform its AND operation with our bit set. If it is equals to 0, it means that character doesn't exist in our allowed string, and we will decrement our lizard and we will not check for further characters, and by the end of this loop we will finally return our lizard. Let's try run this now. My network is very slow, I guess. Okay, let me just reload it once more. Yeah, so let's try run this again. Yeah, it's working fine. Let's try submitting it. Yeah, it's working fine. So yeah, that's all for this question. I hope you enjoyed it. If you still have any doubts, you can post in the comment section. I will surely try to answer them. Bye guys, see you in the next video. Till then, keep learning and stay curious.